Good morning. Okay, so we are now starting our next unit, Module 3, which will be graphing quadratic equations. Okay, so we're still working with that x squared value. And before, what we've been doing is just looking at those equations as expressions, and multiplying the polynomials, factoring the polynomials, but we really haven't put it together with a graph. So that's what we're going to be doing with this module, seeing what the big picture is. Okay, so the first thing I want you to make sure you do when you get these packets, and this is a large packet, so we want to keep track of it. Make sure you're putting your name on here. So that is not your name. You're going to put your name. This is the key that we're going to have here. And today's date, which is 12/19. And then under Bell, just put the period that you're in. So this is period 2. Okay. So complete the following statements. The standard form of a quadratic equation is... Okay, so just like in linear equations, we had y equals mx plus b. That was our standard form. The same with quadratic equations, and we have gone through this before. We have an equation, ax squared plus bx plus c equals 0, or you may see it as y equals ax squared plus bx plus c. Okay, the reason this is standard form is because the exponents are in order of descending value. So this is x to the second. So this 2 here goes first because this x over here is x to the first. We don't write the 1 there. It's just like all those invisible ones that we have in math. We don't write them, but they are still there. So this is x to the first. So in descending order, x to the second would go first, and then x to the first, and then the value that we have, the constant that doesn't have any variable with it, would go last. And sometimes those are going to be set to 0. Sometimes it's going to be set to y equals. So either one of those, be familiar with. The curve formed by a quadratic equation is called a parabola. Okay, and that is that U-shaped curve. So on a graph, that would look like, do please get into the habit when you are going to be showing what these look like to use straight edges. It just makes for a better graph and more readable. Label our axis, x and y. And then, of course, this is always 0, 0. And just to give you an example, it's a U-shaped graph. So we'll just do something like that. Okay, the graph will continue. So what is it doing? It's starting here, and it's going down. It hits a minimum, the lowest point, and then it starts going back up. Now, this is not the perfect U-shaped. Let me show you one. Okay, there's a much better parabola. And the reason I'm pointing this out is because we want our axis of symmetry, which there is on the parabola, where there's a point down the middle of the parabola, and it's exactly equal from right here. So any place on here, from here to here, is the same distance as it is from here to here. This is called our axis of symmetry, which we'll be getting into in a minute. And I'll just put a little bit of a dotted line there. Okay, so from here to here, the exact same distance as it is from here to here. And that works here to here, here to here. That's the axis of symmetry. So if I took this paper, folded it in half along that line, it would be, those two lines would be right on top of each other. That's the axis of symmetry, which is what we're looking at next. Now, to get that axis of symmetry, there's a formula, and it's called x equals negative b over 2 times a. Notice in the formula we have a. There's our a. Ax squared plus bx, that's the b here, plus c. We're not using c in this formula, but we will be using c. Okay, so that's where those letters come from, the coefficients that would be in front of these variables. Okay, the vertex, if the vertex is the highest point on the graph, it's called a, so that would mean that on this is our vertex. For this graph, it's going downward. So this is the lowest it goes, that's the minimum. A maximum looks like this. It's coming up, it only goes to a certain point, and then it starts coming back down. We call that the maximum. So if a vertex is the highest point, looking at this, for this graph, this is the highest point. It's called a maximum. If a vertex is the lowest point, it's called a minimum. Okay, so what you can do right now is pause the tape and get that part filled in if you didn't do it while I was talking. So you'll pause the tape there, and I'm going to continue on with this part of the lesson in another tape.